So let's start with the measurements in a Wi-Fi positioning system. So first, I'd like to remind you with the big picture. So in a Wi-Fi positioning system, what information do we use to locate the position? So we can use the received signal strength indicator, the signal to noise ratio, or other metrics. Then you have to think about how to get this information. It might be through the network infrastructure, so for instance through the access points, or through the mobile devices themselves. Then you have to think about the algorithms you want to use to locate the device. So it might be a GNSS-like algorithm or a fingerprinting algorithm. We'll see later what it is. And for the fingerprinting algorithms, you have to wonder how to build the fingerprints and how to relate an RSSI sample to the fingerprint database. So what can be measured? The received signal strength indicator is a raw signal information which is available on many devices. Usually it's provided in dBm, so it's dB related to the milliwatts. Then there is the signal-noise ratio, which is given by the signal on the noise in milliwatts or signal minus noise in dBms. Then the time between the transmission and reception can be used, but it requires very accurate clocks such as in the GPS. And you have to ensure no delay between reception of the packet and its time measurements, so your network stack must be built for that. Usually it's not for regular Wi-Fi devices. So we'll focus on the RSSI through these courses because it's something we use in a lot of systems. So it's the power received by the device for one signal. It's computed by the Friis formula in free space, so it means through the atmosphere, and it's generally given in dBms. So here we have the formula in milliwatts, and later on we'll see what it is in dBms. So it says that your received power on the transmitted power, which is the wave fading, equal your antenna gain on the receiver multiplied by the antenna gain on the transmitter multiplied by lambda, which is the wavelength, on 4 pi d, which is the distance between the receiver and the transmitter, squared. So how do you get the RSSI? On Windows, you have no open source nor free software to do that. There is NetStumbler, but it's not maintained anymore, and there is no programming interface. You also have the native Wi-Fi, which is not open source, and you have no guarantee about the results. On Linux, you can resort on the wireless tools utilities, which are based on the Wi-Fi beacons and must be used from the client device, so the mobile device, or the RadioTap library, which can virtually read and measure any packet on the network, which can be used from the access points, the mobile devices, and so on. So there are several problems to get signal strength. Driver issues, so not every Wi-Fi card will be supporting IW-List or RadioTap. Some use vendor-specific interfaces, such as Prism for Broadcom. And there may be license issues, such as Apple with iPhones and iPads. So in Apple, you have a license which says that you cannot use Wi-Fi RSI measurements to locate devices. Then, given which device performs the measurements, you may or may have not some limitations. So access points may require to program the access points, so mainly through an open source firmware. You can use OpenWRT for instance, and to have access points which are compatible with the measurements. With the mobile devices, your problem will be to have a lot of mobile devices models, so as many developments as at least the mobile devices operating systems versions you have.